Welcome to a video on inverse trig functions with antiderivatives. Got a good one for you today. This is going to be require a little bit of thinking, which is fantastic, wonderful. We haven't really touched much on the inverse trig functions with antiderivative other than just the basic ones. So we're going to touch on this more and start to get more on the complex side. More, I call that the fun side of calculus. A couple of formulas here that you should know is that this is an arc sine formula here. So this is arc sine. Technically, it's u over a plus c. So if you see something like this, it's just going to be an arc sine problem. Okay, like this. So you can kind of see this is going to appear here for this first example, but I'm going to go through and show you why this is indeed true by using this problem. If you see du over a squared plus u squared, this is going to be 1 over a arc tan of u over a plus c. And then I believe it'll be this problem over here is the one that I'll play around with. I'm going to show you that. And then I'm going to have this du over u square root u squared minus a squared. This is going to be 1 over a arc secant of the absolute value of u over a plus c. And I believe there's a problem on the next page that I will talk about that with. Okay, so these are the formulas. So let's go ahead and get through this. So if you have these formulas memorized, this answer is not that big of a deal because your u value is going to be 5x, your a value is 2, and then you're going to be good from there. Okay, but this will require a bit of u sub as well. I believe there should be a 1 over a right here. We got an limb saying there should be a 1 over a. Is that right? No, it's actually not right. It should be 1 over u. You ignore that. I went on a limb, and I was wrong. Because I was looking at the answer. I was like, is that 1 over 8? No. So you do have to do u sub for this. Because this one is a little bit more on the complex side of things. So let's go for it. So what I'm going to do here is I want to rewrite it so it becomes an a and a u. So this becomes integral dx all over square root of, well, 4 is 2 squared because I want to write this in terms of squares, minus 5x, all being squared. So this is going to require a u sub. So let u equal, because again, this is, I was jumping the gun over here because this u value changes this problem up a little bit. If this was just an x squared, then yeah, you can use this formula. Okay, this is just an x squared, but you have 5x squared, so it's a baby u sub problem here. So this only works when it's just like if this was x squared, then you could use this formula. Of course, a baby u sub here, so this is 5x du equals 5 dx. So you're gonna get 1/5 du equals dx. This is gonna give me 1/5 integral of du all over square root of 2 squared plus u squared. And now I'm capable of using this formula. Now I'm good to go. Okay, so this is going to equal 1/5 arc sine of u over my a value. In this case, a is 2, plus c. Plug in our u, 1/5 arc sine u, we said is 5x over 2 plus c. And there you go. That's it. Okay, so we're going to do a problem similar to this right down here. So we're in the inverse trig section, so it's easy to recognize this because on the notes I'm going to tell you to use inverse trig. But on this one right here, you're thinking to yourself, all right, maybe I could use partial fractions to rewrite this. Nope, doesn't factor. It's not going to work like that. So we're starting to run out of ideas here from what's in our bag of tricks that we currently have. So I'm going to rewrite this by using a complete the square so that I can square this right here. So this was, it gets a little bit on the tricky side. So I'm going to do a little bit of side work here. So if I have x squared minus 4x plus 7 I want to make this a square. So I know if I want this to be a square, you need to divide by 2 and square. That's the number that's going to be able to square this. So if I divide a -4 by 2 and square it, that's going to give me a 4. So I want this to be x squared minus 4x plus 4. I want that. Okay? But in order to add 4, I have to take away 4, just like that. So now I have this right here, perfect, and then I just need to play around with that a little bit. So it's going to be x minus 2 all squared plus 3. So essentially I can now rewrite this as dx all over x minus 2 all squared. This is going to turn into an arc. So I need my, again, it doesn't matter A or U because it's, you can't see that. It doesn't matter what order A and U is in because it's just an additive property, cumulative law. So put this front, no big deal. The A, so if my A value is not 3 because I have to square it, but what if I take root 3 and square it? That will give me this right here. This is the same thing as this over here, and now my A value is root 3. So once I'm here, I'm golden. Let's use this formula. So there's no, we could use a U sub, but what's going to happen here is when I do the U sub, du is going to end up equaling dx because there's no coefficient in front. So I do not need a U sub. If you wanted to, you could. You'd see that nothing's going to change again because the coefficient in front of the x is 1. The du will equal dx. So I can just go right to my arc tan here. So it's going to be 1 over a, which is root 3, arc tan of u, which is going to be this x minus 2 all over, just double check my work here, all over root 3 plus c. And there you go. So right here, this is the problem that you probably need to be working on a little bit to understand it more. If you're not understanding it this very second, you know what, you gotta let it marinate a little bit. It'll sit in there, it'll be fine. So well, you'll be fine. The reason being is because we're going to be seeing a lot of these problems come up with he's completing the squares, playing around, creating situations where I have some type of u squared plus a squared, or a squared minus u squared, or u squared minus a squared with a u outside. Okay. So this problem right here, we're going to need to play around a little bit. I'm already looking at, okay, this kind of looks like an arc sine because it's underneath the square root. We're going to have to play around with this a little bit. Okay, so I want to somehow make this into a squared, so I'm going to go ahead and do this on the side. So negative x squared plus 6. I want to make this, 6x. I want to make this so I can complete the square. So by doing that, I'm going to want to, I'm just trying to see here, with this negative is the only thing that's throwing me off a little bit. It'll be fine. I need to cut that in half, which is going to be 3, square it, I'm going to get 9. But I can't add 9 without taking away a 9. Okay? So here I am. I'm actually going to take out a negative of this part right here so that I get x squared minus 6x minus 9. No, this should be a plus 9. Minus 9. So essentially, I'm kind of like switching these two because this negative will throw me off a little bit. So I need to make this so that I can complete the square. So I'm taking out the negative right there. Essentially, I'm just swapping the plus 9 and the minus 9 because in order for me to complete the square, this needs to be a positive right here. Okay. So now I can complete the square is x minus 3 all squared minus 9. Now I'm actually good to go here. All right. So this is going to give me, rewriting this now, 1 over. If you don't mind, I'm going to kind of flip-flop where these are. Oh, this should be a plus. I just said I was going to flip-flop these, and I didn't. I'm sorry about that. Flip-flop these. So the plus 9's on the outside. The negative 9 I put on the inside, but I took out the negative so that it became a positive. So yep, this is a positive. I was going to say, this is throwing me off a little bit. So to rewrite this now as an a squared minus u squared, a squared is going to come here as 9. So since 9 is a squared, I'll just do this. 9 minus x minus 3l squared dx. The 9 is going to turn into a 3 squared. Okay. And now I'm set up. I could do a u sub. Again, my coefficient in front here for my u is a 1. So du will equal dx. Do not need to do a u sub then. I can just go ahead and use my formula. So this is going to be arc sine of my u value, x minus 3 all over my a value, plus c. That's it. So again, this one a little bit more confusing because that negative is there. It required an extra step here to take out that negative. But other than that, there you go, completing the square. We got a couple more problems here we're going to do based on completing that square. And here we go. So we have the integral of x plus 2 all over root 4 minus x squared. So this one's actually going to require a bit of a rewrite. Because I cannot do u sub to get rid of the x plus 2. There's really not much I can do here. I can't even do my arc sine or anything like that. Or arc, yeah, I'm looking for arc sine because of how this is written. So I'm going to want to do a complete rewrite on this. I'm going to rewrite this as x over root 4 minus x squared dx plus 2 over root 4 minus x squared dx. So now I just have two separate problems. This problem is super straightforward. This is arc sine. Okay, not a big deal. This one is a u sub. So this is just a problem where I got two different things going on here. So if you don't mind, I'm going to do kind of, I'm not as blue. I'll do the blue part first because that's actually the harder one, which is the stuff that we learned quite a bit ago. This is a u sub, so let u equal that 4 minus x squared. So the du is going to give me negative 2x dx. So negative 1/2 du is equal to x dx. So this is going to be rewritten now as negative 1/2 1 over root u du. So this is going to be negative 1/2. Antiderivative of 1 over root u, which by the way is u to the negative 1/2, is going to be 2u to the 1/2, which is going to become negative u to the 1/2, which is going to become negative u right here is 4 minus x squared. And then this one, super straightforward. This one I'm black because, well, my a value is 2. My u value is x. I really could just use the formula. I just happen to have a 2 up front. So it's going to be 2, so plus 2 arc sine of x over 2. Yep, just double checking my work here. Plus c. There you go. Put my two colors together, and boom, answer. Okay. Next problem. Ooh, sorry, I was not expecting this video to take so long, but hey, it is what it is. Next one. Oh, this is going to be a fun one. Yeah. Okay. This is another one where we want to do a split up with a u sub. This one is a split and add. Split and add problem. Okay, because I want to be able to split this up so that a u sub can work just like the last problem. But if I split this up, I'm going to get 2. If I get 2x over all of this, my u sub's not going to work. Because let's kind of move forward real quick. What is u? If I set this equal to u, let's say that I do. Okay, u equal x squared plus 8x plus 25. And du is going to equal 2x plus 8 dx. Well, that's not going to work because that's a plus 5 right there. So let's play a game of, let's make that an 8. Woo! Take away a 3. So now this is going to give me what I want. It's going to give me this 2x plus 8 all over x squared plus 8x plus 25. It's going to give me that. So great. I'm awesome right here. But then don't forget about that minus 3. So minus 3 over, well, x squared plus 8x plus 25. Okay? Dx. So again, I have two different problems here, starting from my green. So I'm going to go ahead and finish this one in my maroon because it's already set up. So I'm going to say that I already have this du set up. So du is going to be equal to du is over u. It's perfect. So this is going to give me ln of u. So this is going to be ln of x squared plus 8x plus 25. Awesome. That's the left side. The right side, this is going to turn into an arctangent because you have nothing on top and you have some type of polynomial on the bottom. So I need to make this so I can square it. So I'm going to change this into 3 over, well, x squared plus 8x. If I cut that in half and square it, I want a 16. So if I want a plus 16, I need to break this 25 up into a 16 and a 9. Or you could just add 16 and then take away 16. Both methods work. Regardless, if I take away 16 from that 25, I'm going to get plus 9. I know I'm squeezing it, but I have this right here. I have that 9. So this is going to become 3 over x plus 4 squared plus 9. So a squared is 9, so a is going to be 3. Don't forget your dx. So from here, it's arctan, so minus 3. 1 over 3 times 1 over 3, because that's my a, arctan of x plus 4 all over 3 plus c. Clean it up. I'm going to get this ln of x squared plus 8x plus 25. I actually do not need this absolute value because this is always going to be positive. Minus 3 over 3 is 1, so just arctan of x plus 4 all over 3 plus c. All right, totally get it. These problems are bears. I get it. It's just going to take lots and lots of practice here. Okay, last problem here. We'll try to get this done in a couple minutes. It's a definite integral. It's great. So when we start to do subs, we'll be fine. So this looks like this is going to be a straight up u sub problem. So is it easier to get rid of the arc cosine? You can't get rid of arc cosine. Or easier to get rid of the square root one? Because in the past I've said, oh, if it's a square root, your u sub is pretty obvious. Well, arc cosine is so complicated. There's no u sub that's going to help us out here to get rid of arc cosine. So if I can't get rid of arc cosine, let's let u equal arc cosine and hope for the best. If this doesn't work, we got to try other avenues to see how we can do this, possibly integration by parts. So du is going to equal, well, arc cosine, if you remember, is going to be negative because it's cosine, 1 over, this should be an equal sign, 1 over 1 minus x squared dx, which is totally awesome because, well, I can just say that negative du is equal to this 1 over root 1 minus x squared dx. So this just goes away. Turns into a negative. And I'll do my bounds in a second. So this just turns into u du because I let arc cosine be u. And that dx, the 1 over square root of 1 minus x squared is gone, turns into a du. Awesome. Let's plug in my bounds, my bottom bound. If I plug in a 0, arc cosine of 0 is, when does cosine equal 0 at? Pi over 2. And then plug in a root 2 over 2. When is arc cosine root 2 over 2? You need to know this. Pi over 4. Just looking at it. Make sure I'm not too crooked. So I'm going to get pi over 2, pi over 4. I'm actually going to flip my bounds here to get rid of that negative, which is actually going to work out because pi over 2 is a larger value anyhow. So I have the antiderivative of u is going to be 1/2 u squared. Plug in a pi over 2, pi over 4. I'm going to kind of let the arithmetic come out to you. You can try the arithmetic and everything. I'll just tell you what the answer is just to save on time here. 3 pi squared all over 32. And there you go. There is the inverse trig with antiderivatives. Boy, is that a doozy. Just is going to take a lot of practice. So make sure that you work on your daily work. Just keep on working on it. Even when after you submit it, keep on working on it.